All right, this is Stuart Mullen, Range Development Services, and this video is going to cover some really important time and money-saving design considerations, and that will help coordinate between the design team, architect, and the trades, mechanical, electrical, plumbing, as well as the GC for bidding purposes, their trades and what to anticipate. And it's going to be at least a probably 15-minute video that covers the key elements, but not all of them. There's a checklist that I've developed over the years that is about 200 line items long. I'll give you a glimpse of that in a few minutes. And it goes room by room, space by space, issue by issue, trade by trade. It's organized literally in each of those ways with notes on each. And we deploy that on each of our range projects because it further, on top of the information I'm going to share in this video, brings that design process together and the realities of constructing in the field, what's shown on paper. Those are two different media and scenarios, and what's on paper, building it is different from drawing it. So this process through the design process with a GC at the table in the conversation, already pre-negotiated terms and conditions and so forth, fees, general conditions, all that's known, and the GC is selected to do a negotiated deal while we're in the design process, so the team is more unified when it comes time to full pricing, final pricing, closing the loan, and then certainly a wild benefit during construction. So how does a range bay work? Let's remove all of the mystery from what this looks like. So here's just a cross section of a range. And so you're looking through a wall that would exist. The walls are three options, really. If it's big enough and it makes sense and you have qualified contractors, typically more so in the larger urban areas, larger metro areas, are a tilt panel. So tilt panel construction has some benefits, typically for larger scale, and GCs and architects know this, but on a smaller range, we've got one now that's just 10 lanes, and that one probably is going to be CMU blocks filled solid. So every 3 or 4 courses of block, you come back in and use the same mortar that you're doing the courses with, and you fill those blocks solid so there's no voids. And that's on all 4 walls of each range bay. And I say bay, that's a room, basically. And then you have individual lanes in a bay. So in this case, whatever it's, I guess, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. And what's interesting here to note is that this drawing represents a bar joist roof methodology, roof structure. And in that case, ceiling baffles are required. These are steel AR500 panels. They're square. They're on this angle that ensures that when a shot is fired, even if it's an errant round, just right, almost directly straight up, or when they hit, further down range, those angles are precise in terms of how they're hung, so that it's safe for the shooters. What happens to a bullet when it goes down range? For the past 5 years, it just goes into a rubber trap. No steel traps have been installed on any ranges I've been involved with, and very few otherwise. They take up way more square footage. They cost 3 times as much, and the volume's never, in my opinion, never there, never enough to justify all of the other moving parts that are in a steel trap, which typically would include the requirement for additional square footage, not shown here, behind the trap structure to access and harvest the lead. Then you might have an option to have an auger system that automatically removes the lead, and then you have a dust collection unit, and the list goes on. The rubber is more simple, cheaper, smaller square footage consumed, and just as safe and capable for all calibers, full auto, etc. So the ballistic package includes those baffles, the trap, the target retrieval system, the stall walls, the side walls that separate the shooters, right? On which the ballistic equipment manufacturer will provide their controller for the retrieval system and the table that demarcates the firing line. And generally, the only other thing that they might supply is sidewall sidewall sound abatement panels. That's either in PEP or some ballistic rubber options. And then I've got some other super quiet, not cheap, but very quiet sound panels that can also be used. We've deployed in several range locations, and you can tell a difference. And that's an important element that for the owners from an operational perspective, they need to take into account. Okay, so under bar joist construction, typically the clear height needs to be 16 feet because you have to hang the baffles. They span from the bottom about 8 feet off the ground to 10 feet off the ground. And then above that 10-foot mark, you need some space. And then you have these duct runs that are just graphically sliced, but the duct run would come all the way back to the firing line. So air is supplied by a diffuser not shown up in this corner behind the firing line on this back wall, and it pushes air across the firing line in a laminar flow so that all of the particulate is pushed downrange and then is evacuated, exhausted into this unit here where it's filtered. 25%, once it's filtered, is purged, and 75% is pushed back into the space through the ductwork and back up into that unit, so back out of the space, and then back again into the through the diffuser. So that's bar joist. The other element in a bar joist is these baffles, which are required for bar joist construction, will be suspended and connected to the bar joist with unistrut and airline cabling. So all four corners of each of these panels, so just call it one panel, 4 foot wide panel per shooting position, because shooting positions are typically at a minimum 3 feet wide, typically no more than 4 feet wide, with the exception of maybe one that would be set aside for ADA compliance. So it would be 5 feet wide, and 5 foot wide for maintenance purposes to be able to get downrange and harvest the lead out of that trap. We'll talk more in this process about that maintenance effort to pull lead out and clean the range that has some design implications, but I'll save that for another video. So that's the ballistic package. The ballistic manufacturers do not supply downrange lighting that would need to be, in this case, mounted to the tops and backs of each row of baffles. So we'd have to get into, depending on the width of the bay, a calculation, a formula that I've got to determine the number of lights per row of baffles. Those lights will be the GC's responsibility to have electrician provide the fixtures and the labor to install them. And of course, they need to be accounted for back all the way to the panel. Then in the stalls, you have power necessary to recharge the battery on these wireless units. Sometimes they're cable driven, and of course that consumes power. And then the control pad obviously has power to send the retriever down a certain number of yards, turning and programmable. All that good stuff is power driven. Needs to be accounted for on the panel, and the equipment manufacturer will do the installation not only of these stall walls and the safety ceiling. The safety ceiling goes really above and downrange a little bit. It goes above the stall walls. And then from the stall walls at back edge back to the diffuser is just a normal office grid system. Sometimes it gets a little bit more fancy if you want to have a different kind of ceiling structure. But what it's doing is not letting air go out of that diffuser and just get pushed up. All the air needs to be pushed and focused past the firing line. So that's why this angled ceiling structure is designed the way that it is, because that radial diffuser will push it. The ceiling will guide that air through the firing line space between the stall walls. Okay. So that ceiling grid and the lights that are in it will be GC's responsibility, and GC's electrician. Those fixtures the downrange fixtures, as well as typically the fixtures that are in the safety ceiling are going to be the GC's responsibility for parts and labor. And then the retrievers and all their electronics will be the ballistic manufacturer's responsibility to supply, design, and install and connect that power connection to the building systems. All right. What else? These units, air units for HVAC, are 8 to 10,000 pounds. They oftentimes, depending on the size of the range, will not be in the middle of it. It's efficient for it to be in the middle because then it's evenly distributed across the width of the range bay, the diffuser. But ductwork, if necessary, can be utilized to push it across when we move those units to where they straddle the wall. If you have a second bay, so let's say you had 8 lanes here and 5 lanes to the right, well, that's pushing the limits, but still you could potentially design that range under that configuration with one air system. If you had 20 lanes, 25 lanes, you'd end up with 2 of these systems. But the thing that's important here about this, from a GC and architectural design perspective, are the loads, because they're, like I say, 10,000 pounds. So whether or not on the wall or whether or not there's reinforcement to this roof system needs to be accounted for in the cost of construction, as well as when you have ceiling baffles, those loads and the unistrut that's connected to them all needs to be accounted for. We've had ranges big enough to where we had probably a $25,000 budget for a lot of these elements. And so the unistrut and its installation will be on the GC. So that connection can't just be clamped unless the architect and structural say that they can be clamped. Typically, they're going to need to be welded in some form or fashion for structural integrity. Because again, each of the 4 corners of these 400 or so pound steel plates connect up, and up. And so you end up with a lot of connections for every single row. All right. There's more tricks to the trade and to getting this design work done for where these controls reside from a security and safety perspective, from an operational perspective for downrange lighting, install in the stalls lighting, and then the lighting that's in this safety ceiling, or excuse me, the get ready area for HVAC directing. All right. What else can I tell you about the range? Finishes, really pretty simple. That's the floors most often are ideally protected and not, beat up through the construction process. So they just look clean ideally, but most often, 9 times out of 10, they will, once the range equipment is completed, GC's responsibility would be to come back in and seal them, just a clear seal. And that'll hold up even to bullet strikes. Sidewalls, sometimes they're left bare. You can just have that exposed CMU block or tilt panel, but other times under a bar joist, you need to plan on painting those walls up to a foot above this 10-foot mark, so 11 feet up that wall. You don't need to paint all the way to the deck, but it'd be the sidewalls. The 2 sidewalls, leave the back wall bare because it's going to be covered up by the trap. And there's no need to paint this wall because it'll have sound abatement material on it, as will the sidewalls near the get ready. But from the firing line, sidewall, back wall, and then this sidewall won't need paint. So the other element that I'll mention here is just this little quick drawing that I put together. And this is a profile of these walls. And what we want to do, particularly with a hollow core concrete plank, is avoid this situation, because sound will jump over that wall, even if it's sealed up and so forth. It's just a joint that's a connection that lets too much sound, in our experience, into the other portions, non-range portions of the facility, and can disrupt kind of normal conversations. So, and secondarily, if this is an exterior wall, we want to minimize the amount of sound that is emitted from the building. And so this finish block wall to the bar joist sitting just flatly on top is not ideal. And so let's go back to this. Even if it's a bar joist structure, just replace this in your mind. This is a hollow core concrete plank coming across and rests 50% on through, I should say, that block wall. Or if it's tilt panel connected, there's a connection there that obviously has to be made. But we don't see, typically with a hollow core concrete plank, it's a smaller facility, and it'll just be CMU block walls. So it would look like this. The bar joist construction typically is going to have connections into those sidewalls, typically going to be tilt panel when it's bigger. And so that'd just be a metal connection into the tilt panel, maybe with embeds, if I recall correctly. So if you have two bays with a common wall between them, two bays side by side, like we were talking about earlier, then both the hollow core planks would rest 50-50 on that wall. And it's just a much better scenario for sound abatement with this penetrating mid-roof parapet wall, basically is what it amounts to. And in this case, it would just run up higher like that. Okay, final thing I'll mention is most cities, towns, code requirement is that rooftop units have to be screened. Well, these things are, I don't know, man, 10 feet tall. So if they're screened from public view, then we got to take into account from a design perspective where the public right-of-way is, and either adjust the parapet height of these walls or plan on a fence screening type of material that needs to be designed from the start. Coming in after the fact, no thank you. That's costly and time consuming and needs to be accounted for in several respects. All right, final thing I'll mention on wall height. One of the benefits to a hollow core concrete plank is that the walls are lower. With bar joist, you get the advantage of space between the tops of the baffles and the bottom of the joists to run the ductwork inside, so it doesn't have to be insulated. So it comes out of the space into this unit, filter bank, and then put back into the heated area indoors, and then is protected by the baffles, and then runs back up to this unit, is conditioned, and then pushed into the diffuser, and all that ductwork is inside. Whereas with a hollow core design, you cannot run it inside. And what I mean by that, I will show you in an image here. That's downrange, but let's look at, that's downrange as well. Here you go. Here is the hollow core concrete plank exposed, and then there's a vertical baffle in this case that just protects the light. As you can see it, you don't see the fixture, but you see the light shining on this support structure for the rail. That's the target retriever rail. So that connection to the roof structure is protected behind that 12-inch tall baffle that's got rubber on it. It's L-shaped, bolted into the ceiling, and then the vertical part comes down. It's protected with ballistic rubber, and it protects the light and that connection. But otherwise, it's exposed, and a bullet could strike that, and you'd have to shoot the same spot over and over and over to ever have any kind of problem with it. Looking backwards, back to the firing line, the trap is behind us, so no live fire going on. You see the backside of those baffles and how lights are installed across it. In this case, they use just a real simple fluorescent light fixture. And then you see the connection that's made with the support for the track going back up behind it as well. No other utilities, nothing can run up and down the range. It's too expensive to try to protect it. If a customer or guest sees it, they'll shoot it, and we just effectively really need to avoid anything being exposed. Just need a clean environment, just like this. All right, just skipping through, just to put in your mind's eye, we do typically want a leave out on the range bays for construction purposes. Here's a good example. Leave out here coming from, I'm not sure where the outside is, but nonetheless, to be able to get into this space with all of that equipment, ballistic equipment, is really important with a forklift. And so this leave out gets backfilled. Once all the range equipment is 90% done and completed, it gets backfilled, finish that wall. On a hollow core plank like this roof structure, we've got obviously designed for the orifices to connect to the HVAC system. So that's got to be accounted for in the design process. And here are just some other images of some hollow core planks flying overhead, finishing out. Should all be somewhat helpful. And then the rest of this is the non-range bay construction, just kind of typical retail construction. As you can see, we planned a small range recently that just had, the plan was for wood instead of metal studs. So if it's small enough, you can get away with it. But here's an image of hollow core concrete plank roof structure with the duct runs outside, as I mentioned earlier, just so you get a sense of what that looks like. The units they've not been placed yet in that particular case. There's a members lounge, retail space. We'll get down here to some more images of hollow core planks. There you see the joint. It just sits right there like that. In this case, sidewalls were not painted and they ran ballistic rubber up and down the entire length of the bay, which is an option the owners might have interest in. Here's a scenario where we have access to a storage space that's downrange. The trap, as you can see, these little rubber is just to the right. Those rubber granules have spilled out. And so this has a little wing wall of AR500 steel that protects the hinge side of the door. And you can see a strike or two there, but there's no hardware on this. And so if you see a door to storage downrange, then that's what it'll look like. And here's what it looks like from uprange. Right. Yeah. So there's the door with that flank deflector. And then there's one of the retrievers that goes right past it. All right, here's more details. Oh, electrical coming especially on a hollow core plank, has to come through that sidewall. Can't run electrical on the roof. So it's got to come from inside the non-range portions of the building. And so for each of the baffle locations, the lights, as you see in this image, well, those connections are being punched through that sidewall and coordinated so that they're protected by the baffle system. All right, video turned out to be much longer than I expected, but I hope this gives you a good sense of what a shooting range looks like. Here's a taller baffle system right above the trap, so that the air ductwork that's exhausting is protected. You can't see it. It's up behind that. Okay. The final thing that I promised to mention at the outset of the video is this checklist. And this is, again, it's broken down by room or space. And so we have interior, exterior, and then the range bays. And as you can see from this list, it is extensive because we go from row 5 right here to row 36, and then from 36 to 116, from 116 to 202. There's a bunch of issues. So let's say security and painting and lighting and all the other things that need to be accounted for, they're all accounted for in these parent-child relationships. So we have this, there's a great example, gunsmith. They need power, they need, you're going to read this, this is super simple. Well, it gets missed all the time, but to come back after the fact is going to cost you time and money to install an vent for gun cleaning and solvents and all the fumes and so forth in the gunsmith space. Well, this checklist, when given to the contractor and to the architect, it's in the plans. Everybody knows about it up front. It's easy. It's no big deal. The roofer is going to know, hey, I got to make a couple of penetration. If you don't remember it until you're under construction and then the roofer's got to account for it, well, it's going to cost you a lot more than it would if it's planned from the start. So one very simple, straightforward item, but there's 200 plus on here. And it includes a lot of the calculations for the loads that you really can't get unless you go through the design process. Well, I've been through it so many times. I can provide you with insight on those load requirements for the weights of the units and the baffles and all that information, so that your design team has it from the get-go without having to go elsewhere and try to find it. So hit me with questions, concerns. Glad to discuss and debate this process and how we've proven that you can get through a last range project was a $7 million total project. The GC scope was about $5 million, and we had about $175,000 in contingency, and we spent $7,000 of that $175,000 contingency, in part because we had a great team, and I think in part also because of all the information that we deployed through this checklist and through this process, some of which we've just started to kind of scratch the surface on in this video. I'm Stuart Mullen, Range Development Services, here to help if I can.